Okay, in this video we're going to talk about writing a linear equation giving graphical information. If you just watched the previous video, we did it off a graph of points or off a table of points. But the idea is these are linear equations. Linear equations, linear equations just aren't that complicated. What does it take to make a line? 2 points of information, or knowledge of 1 point plus the slope or the slant will give you that line. So if we have that information, we should be able to make the equation for a line. So this is very typical of a graduation type test or an MCA type test. Is they give you a picture of information and ask you to generate the equation off the graph. So there's 2 ways you can do this. One is more visual and the other one is more point by point mathematical. Alright, so here's our line of points, and we can see it is in fact making a line, and we're talking about earnings for somebody over the course of several weeks. So looking at this graphically first, there's an equation model for lines called slope-intercept form, which is y equals mx plus b. Okay, that's probably the most prevalent linear equation model that you ever see, where you have a dependent variable depending on x, an independent variable, and this is telling you the slope of the graph, and the b is the y-intercept or the starting point of the graph. Okay? Now that's what makes this a little bit interesting, because in fact this is not on the y-axis. This is after 1 week we're at $75. Now if you can visually see the slope, you can probably write the equation in short order. Okay, now the slope is how steep the line slants, which we've been talking about is the change in y compared to the change in x, or what we call the rise and the run. So if you look at this, at 1 week he was at $75. After a second week he's at $100 of savings. So how much did the money rise? Our rise would be $25 in 1 month. So if slope is rise over run, which it is, and we can see visually that we're rising $25 as we run horizontally 1 unit, the slope is 25. Okay? That's the slope part of the linear equation. Okay, well what about the y-intercept? Well, essentially again, if you look at this visually, if we were going to go to the y-axis and say, where is this going to start at? Well, essentially, we could just continue our pattern with the slope, and we'd be going back 25 as we go back to 0 weeks. So essentially, I'd like you to be able to see that, you know what? If I take 25 off of 75, at the 0 week, he must have already had $50. Okay? So the y-intercept point would be $50. The slope is $25. So the equation would be y equals 25x plus 50. Okay? That's a visual way of seeing the slope and seeing that the y-intercept would in fact be 50. Now that isn't so hard if they give me a point right here so close to the y-axis that I can trace back. You don't always have that information. I could have said, you know what, I'll give you this point here and this point here. Now give me an equation for the line. So it's nice to see it visually like this. This is the equation. But another way we can do this is just to physically put points of information into an equation model and get the equation that way. Okay? So I want to review with you. There are a couple of equation models you use all the time. We just did this one. The other one you can see is called point-slope form. Alright, now point-slope form is very useful to plug points of information into. So this is review if you saw the other video. Otherwise, how does point-slope form work? Point-slope form says, you give me 1 point of information plus the slope, and that's good enough to make a line. So it should be good enough to form an equation for the line. So what we do is we pick a point of information, and in fact, we're going to have to get the slope, so let's look at 2 points. So here's my 2 points, and I've got 1 month in, I'm at $75, and 2 months in, I'm at $100. All right? Now from that information, I can figure out the slope, okay, which we need to remember now how to do slope. You've probably done this 1,000 times in high school, but it's the difference of the y values divided by the difference in the x values. So if this is our first point, we call it x1, y1, x2, y2, and the formula says take the difference of the y's, y2 minus y1, and divide by the difference in the x's. You're finding the amount of change in the y variable, the money, compared to the change in the weeks. So if we plug in here, we will have, let's see, y2 would be $100, minus y1 is 75, and we've got 2 weeks minus 1 week. And you know what? It ends up giving you the truth, and the truth is there was a $25 change in a week. Okay, so you can see it visually. If you can see it visually, here I've actually figured it out. The slope is 25, just using 2 points. All right, now once you have that, the slope, you could take either one of these points and plug it into point slope form. Now how does point slope form go? Now what it says is the form is y minus the y coordinate of a given point equals m times x minus the x coordinate of a given point. All right? So I can see I've got a slope value I've figured out from my points. I can take either one of these points and plug them into the equation model. I've already selected this one. It's got the smaller numbers. And I'm going to plug them into point slope form. So y minus the y coordinate of my given point would be 75 equals the slope, which is 25, times x minus 1. Okay? Now I get to do my mathematical simplifying here. Distribute. Y minus 75 equals 25x minus 25, I believe. And I want to get y by itself. When you make a formula for a variable, you're getting that variable by itself and showing how you get it from the other variable. So y equals 25x. This is going to be positive 50. And lo and behold, I arrive at the same equation here that I generated visually. You have to have the slope and the y-intercept to get into this equation model. But what I'm saying is you can go and take the points of information and run it into point slope form and get the same identical equation. Okay? That's how that works if you have a visual graph. Now I've got one more example over here. I've got somebody that likes cookies. My question would be, who doesn't like cookies? All right, so you can see what's happening to the cookie line. It's going down, right? They're being eaten up. And it looks to me, if my eyeballs are working this morning, that after 1 minute, there's 20 cookies left in the cookie jar. And after 2 minutes, looks like it's right between 20 and 16, so that would be 18 cookies are left in the cookie jar. Can we make an equation for this graph? Visually, I would hope the answer is yes, I can. I can figure out the slope and the y-intercept just by looking at this. Okay? So what are we doing? Well, we're going down as we go over. So if this is at 20 and this is at 18, the rise is not a rise at all. It's a fall, but the cookies are going down 2 every minute. So visually, I'm seeing that the slope is -2. Okay? Now, that's a nice piece of information. You also need the y-intercept. Again, tracing back, if there's 20 cookies after 1 minute and we're declaring that they've been going down 2 every minute, then when you first started, you'd have to go up 2. So essentially, that's going to start this graph at 22. Okay, so the y-intercept, this point here, if we had it graphed, it would be at 22. So you put the value for slope and y-intercept in, and you have y equals -2x plus 22. Okay, one of the things you're going to see is a lot of times they'll change this to the appropriate variable for what's being talked about in the problem. Y is essentially the number of cookies. It's going down 2 every minute, and it would have been a starting point of 22. Okay? So there would have it. All right? If we can't see it visually, we're going to have to use points. Pure and simple. So I take 2 points. After 1 minute, there's 20 cookies left. After 2 minutes, there's 18 cookies left. And then I'd be using my slope, getting my slope, and I would get -2 if I do the same routine I did before. And then I'd be plugging it into point slope form. Okay, y minus y sub 1 equals the slope times x minus x sub 1. You simplify it down, and you're going to end up with the exact same equation that you had before. Okay? So, 2 different ways you can decipher this linear information. You can do it literally visually, seeing what the y-intercept would be, seeing the slope, putting in the model down, or you can take points, figure out the slope, use point slope form, and arrive at the same result. This might be the tar road, this might be the gravel road. The bottom line, you want to get to where you want to go. Okay? So there you go. Writing linear equations, giving graphical information, and putting them into slope-intercept form ultimately. All right, thank you.